Hello, and thank you for joining us today on our July webinar. This month we figured instead of doing one big topic on a certain subject in file transfer, we're just going to take some questions, either from the audience or questions that came to us before when we first created this webinar idea. So anyways, if you have any questions during this webinar, you can enter it into the GoToMeeting box, GoToWebinar box, and I will go to through them at the end of my presentations. I only have about 6 or 7 questions I've compiled from the past. So, welcome to my webinar. My name is John Tkachevsky. I'm the president and co-founder of Unlimited Software, the creators of FileCatalyst software product suite. And check out our blog. We have lots of interesting articles there about file transfer, software development, and anything else that is related to privacy and security on the web. So it's a good resource to find out what's going on in the file transfer space. So question number 1, what is file transfer acceleration? Well, this is a very basic question, and this is exactly what we do here at FileCatalyst. With FileCatalyst, FileCatalyst is a product suite that allows you to move big data from 2 different geographical locations using the internet. So instead of shipping a hard drive or shipping media, you can transfer these files using the internet. The file transfer protocol that we actually use, it's something that we've built in-house here. We don't use FTP or SFTP underneath. We use a UDP-based protocol that we've built in-house that allows you to move these files, much faster and more reliably than any existing file transfer tools on the market today. Because UDP by itself is just a transport, it doesn't really have any brains. All the brains of like congestion control and reliability have been all built into our application. So we don't sacrifice any of the we don't inherit any of the problems of UDP. We only inherit the positive speed, and all the other reliability and congestion control is built in actually to TCP. So in other words, basically, is if you want to move large files, instead of using FTP or SFTP, you can use FileCatalyst, and then you can move your big data anywhere around the world using a network. So why is UDP faster than FTP or TCP here? The reason I wrote TCP is that TCP is really the underlying protocol that is a problem here. FTP by itself utilizes TCP for transfers. Same does SFTP or any CIFS or like Windows file sharing or folder sharing that all uses UDP as well. TCP as well. So the underlying problem is really the chattiness of TCP. So if I want to send a bit of data with TCP, I'm going to send a small chunk of data, and then I'm going to ask my receiver, did you get it? The receiver will respond, yes, and then I'll move on and send the next piece of data to the receiver, and so on. Every time I send a bit of chunk of data, I have to wait for the receiver to acknowledge that I received it, that they received it. If they didn't, then I'm going to resend that chunk of data. So what this creates is that creates a lot of talking between the sender and receiver and not a lot of sending. With the UDP protocol, the data is flowing constantly. So we don't wait for acknowledgments. We only wait. We don't wait at all, but we only acknowledge the exceptions. So when the receiver is receiving the data, the receiver has to tell the sender, hey, I'm missing, packet number 7, and then the sender is going to go recreate that packet number 7 and resend it to the receiver, so the receiver can grab all the data that is needed to rebuild the file. it sounds like that latency is not a big deal, but it actually is. So here's a file transfer scenario for 100 megabit on a 100 megabit line with 50 milliseconds latency. So RTT is the round trip time, or how long for a packet of data it takes to go from LA to New York and back. So 50 milliseconds is pretty quick, but that 50 milliseconds translates into a slowdown on the FTP. So here's an example. FTP will take 2.5 hours for a 10 gig file, and FileCatalyst will take 14 minutes. Another example, here's an example, LA to London, where you have a much higher latency of 250 milliseconds right now, because you're going much further between two different points. And now see, FTP takes 12 hours, and FileCatalyst still takes only 14 minutes. So whatever example you basically you would ask me here, my answer for FileCatalyst always will be 14 minutes. And so we're basically immune to that, RTT or round trip time for the packets to arrive. We also have a really neat online calculator on our website where you can actually punch in your own details of your line, and you can come up with your own metrics, how much you should be expecting to be getting with FileCatalyst. So if you just go to our website, filecatalyst.com, and click on products, and then on the right hand side you have your tools here. So you have your tools, your throughput calculator, and FileCatalyst versus FTP. So if I click on FileCatalyst versus FTP, now I can enter my information. So let's say I'm gonna put in that example of that we have on that I showed you there on the table. So the first box is your speed, line speed. So here I entered 100 megabits. 50 is my RTT. Round trip time is really easy to get. All you have to do really is open a command prompt and do a ping command to your other destination, and that will give you your rough RTT time. So you can just enter it here, and then your maximum. And if I update this here, you can see here the speed location. So at 50 milliseconds, FTP does about 4 megabits, while FileCatalyst does nearly 100 or 98.5 megabits. And as you can see, if the latency now drops to 250 milliseconds, now the speed here is 807 kilobits. So you're not even getting 100th of the line speed that you really have for that transfer. FileCatalyst, you still get 100 megabits. So it all really has to the question of this revolves around the latency, and to a certain degree packet loss as well. Mind you, on the landline, on landlines, packet loss is probably usually not an issue, but if you do have a wireless or satellite connection, packet loss will also be a problem. So this you can use this calculator to come up with your own statistics for your own line. So let's move on to the next question here. So how are we different from other UDP vendors and UDP protocols out there? The idea of using UDP for transferring data has been around for a while now. We here at FileCatalyst been doing this since 2006 or so. So this is not a new concept. Other UDP vendors have done it as well, but there are many ways how you can process this data, and each solution will be a little bit different. So first of all, one of our differences is our speed. We're actually still the only vendor up till now that can transfer data with up to 10 gigabits. That's 10,000. 10 gigabits. It's going to be at 10 gigabits. What that means is that you can transfer. We actually have deployments on the field with this. We have documentation how you can push your hardware and software to get to that speed, and we can do this in a real environment where you have real packet loss and real latency on the line. So pushing 10 gigabits without packet loss or latency is a lot easier than doing this when you have actual latency and packet loss on the line. Another thing that we differ is that we actually have in our protocol, besides of using UDP, we also have something called file deltas built in. So imagine if I transfer a file and that file then changes a little bit, and then do we need to retransfer this whole file again? With file deltas, we'll just calculate the difference and sense just the difference between the files on the second transfer. And this is all built transparently into the transport. So some other protocols, you might have to run a command line tool to process that. With us, it's all built in and it's completely transparent to the end user what's happening with the file. Another thing where we differ is that our products are quite multifunctional. Meaning that a single product you get a lot of functionality. So for example, with our direct product, you will get functionality like data replication and web-based plugins all in one product. You don't have to purchase another product from the vendor. This ultimately, will save you money down the road, because instead of, buying more and more products, you get one product that does that covers a lot of functionality that your enterprise or your business might need. Same example goes with our web-based products. If you, let's say, you need to be able to send files to an email address or like email distribution, and you need web-based folder sharing for like, like a Dropbox type of solution, this is all built into a single product called FileCatalyst Workflow. Once again, single product covers many different functions for your business. And third of all, where we differ also is the flexible licensing, where we can provide you different models of licensing, either an all-inclusive model where you can buy and get all the functions out of the box, unlimited concurrent connections, and no per seat cost, or you can distribute the client software to anywhere, or you can go with the much less expensive a la carte model where you pick and choose the functionality you want, and then you pay a lot less for the software. You can buy how many concurrent connections you want, which functionality you desire, and so on. So it makes it a lot more flexible for your deployment. You can start with something small and grow with it as your business or your enterprise grows with it. Next question. Why do I need workflow and direct? So as I mentioned here already in my presentation, we have a number of products. We have, FileCatalyst Central, we have FileCatalyst Direct, we have FileCatalyst Workflow, we also have FileCatalyst Central. That's another product that we have. So Direct is really for point-to-point. So imagine you want to move large file from point A to point B, and you either want to use like a FileZilla type of an interface, or you want to use maybe some automation tools where you're just moving the data, or you maybe need a web component to integrate into your existing application. Same with like a CLI or SDK. So it's all about the point-to-point transfers, and the web applications you get, they are really just components that you could embed on your own website or built into your existing application to augment your application and provide accelerated file transfers in the web. Same goes with command line and the SDK. Workflow, on the other hand, is everything that is web related. So imagine it's a web portal where you can do many different file transfer tasks. Everything is initiated via the web with workflow. So for example, some of the major three things people usually want to do on the web is file submission or ingestion, web-based ingestion. So let's say a user comes in, fills out some kind of a basic information form, and then uploads some files with it. So the files get uploaded into a central location, and you as the administrator, you manage where these files go, which storage, which path, and what processes on the back end you want to kick off from that ingest. Email distribution, imagine this is when I have a large file and I want to send a file to a receiver with an email address. So I just punch in the email address, attach the file, and the recipient just gets a download link, doesn't receive the big file in the email, because of course that's not going to go through. And the final mode that people usually want to do on the web, it's web-based folder sharing. So imagine you have a web-based folder and you can, collaborate with other people on that web-based folder, or you can just keep your own files on the web and you can either upload or download files for sharing. So two quite different products. You would need one or the other depending on the workflow and what you are trying to achieve. If you're looking for any kind of a web-based things, workflow is usually the way to go. If you're, however, looking just for the desktop or automation or maybe some kind of an integration into an existing website, that maybe direct might be a way to go. But this gives you a good should give you a good idea what to use and when. Next question: how can you guarantee file delivery? So first of all, what we do, we have a mechanism called an MD5 checksum built into our protocol. That means it's an MD5 checksum really means that we're going to do a bit-by-bit comparison of the transfer after it's done. So once the file transfer is complete, we will initiate an MD5 checksum, compare bit by bit what was from the sender to what was received, and if this file is correct, then we'll deem this a successful delivery. We can also transfer files with temporary file name. So we will do that MD5 checksum, and after the transfer, we'll, for example, remove the fctemp extension on the file. Like this, if you have any backend systems that you're doing any transfers that are expecting certain files to arrive, you could just tell it ignore anything with fctemp. Ignore anything with fctemp extension because these files have not finished transferring. And if you're using workflow, you can also get a delivery receipt either in a PDF or an XML format. So this basically becomes like a little verification piece of paper that's could say that file has been transferred successfully. The XML format is more useful if you need to plug this into other workflows afterwards. Another question: can you resume file transfers? So yes, of course, file transfer can be resumed, can be also automatically retried and resumed. So if a connection drops just for a short period of time during the transfer, we can have something that will automatically retry and resume transfer automatically. The resuming is built at a block level in our application, so that's default is a 32 meg default. So we will resume up to the last successful block that was transferred. If of course you have a much slower speed or using satellites, that block can be lowered, so you don't have to wait 32 meg chunks before you can resume it. Another thing, what we do, we also do we have a smart resume capability. So we will do an MD5 checksum of what has been sent so far versus what's on the receiver side. And only after MD5 passes, then we will initiate a resume operation. There's no point of resuming, doing blind resume sometimes, because that can lead to corrupt files. Resuming with a blind resume, if you're receiving at the end you end up with a corrupt file, there's no point of doing it. Might as well start from scratch. And this is what a lot of FTP and SFTP protocols do. It's mostly a blind resume where there's no MD5 checksum. It just remembers the data offset where it stopped and blindly restarts from that point. And that's why a lot of people experience corrupted files with FTP or SFTP. Another thing what we can do is file delta. As I mentioned already before, we have a feature that will allow you to send just the difference. So imagine if we transfer the file and now this file actually has grown. So we have not really resumed a transfer, but it's just a file that has grown and we want to transfer it again. So we can do an rsync. So instead of sending the entire file from scratch, we will calculate what changed and basically append new information to that file arriving. Are there any limits? Another question. This question, we're talking here more on what's theoretically possible with our transport, our UDP transport, and it also gives you an idea here what we're doing in production and what we're testing with. because we've been thrown into all kinds of situations. So we test and we actually do transfers in production of files up to 8 terabytes in size. So imagine a single file that is 8 terabytes. So we do transfers like that. We also test with and have production environments where we're transferring file sets that contain 4 million files. So imagine this would be a hot folder application where there's a folder with 4 million files, and as soon as the task is finished, it restarts again to look for new files to transfer. These problems are not easy to solve. They require a bit of hardware adjustments, a bit of software adjustments on our end, but this is something we can do, and we have documented cases of how to deal with such big single files or such big file sets. For file transfer speed-wise, we test and we have production deployments of up to 10 gigabit speed. As I already mentioned, we're probably we're the only vendor that can go at that speed, and we have documentation on our blog how to adjust your hardware to hit these speeds. We also have an independent study of that was done at a university in Germany that also confirms that we can get the speed, the 10 gigabit speed with packet loss and latency, and we can show you all this information if this is something you're looking to achieve. On the low end, because we also have clients using a lot of wireless or satellite connections, we also test with speeds as slow as 128 kilobits. Once again, the protocol has to be pretty efficient to be able to run 10 gigabits or as slow as 128 kilobits, and we test with both. So you have a good spectrum here of bandwidth and scenarios we cover. Another limit that sometimes we hit is the latency limit. Once again, this is not on landlines, but this is more on satellite and wireless, but we will hit latencies up to 2,000 milliseconds. Normal landline, let's say extreme case, Australia to Europe, latency will be maybe 400 milliseconds. So that's the extreme. We actually test with up to 2,000 milliseconds or 2 seconds latency and 10% packet loss. Once again, those are for the satellite, especially satellite communications. This is something very handy to do. So these are sort of our limits. We work up to these cases, but regular real life scenarios sending few thousand files up to a terabyte in size is not a problem, and same thing with the landline speeds as well. Tell me about the cloud. Here's another question that came in. So FileCatalyst, being a big data transfer tool, is ideal for moving files to and from the cloud. There are a number of ways to achieve that. First of all our products will run on most public clouds, including Amazon, Azure, OpenStack, etc. You can set up either a client or the server on the cloud and then move data quickly to and from the cloud. The same thing goes with the storage on the cloud. We can also connect to that and transfer files using applications for connecting to the storage, the cloud storage. We also have SaaS or software as a service packages through our partner Compute Next. We can provide you a file transfer package where you just pay a monthly fee. You get X number of X size of the disk space, and you can take advantage of FileCatalyst while it's running on the cloud, and you're just paying a monthly fee. So that's something also we can offer. So that's all the questions I've prepared. Before I go into events, let me just see here what came in for questions. So I'm gonna just give me a second here. Okay, so Somebody's asking here, what are some most underutilized features of FileCatalyst? Any product? Well, it depends really what you're trying to do. I would probably say some of our APIs are not fully utilized. We have a considerable amount, we've spent considerable amount of time developing REST APIs, so you can control your environment, your FileCatalyst environment remotely through REST. I would probably say that's not being used a lot. Another feature that doesn't maybe get enough attention, as I mentioned, is the file deltas, where, you know, when a file has been sent, we can just send the difference. It really depends on your deployment and what you're trying to achieve. But these two kind of come to my mind. Any other questions here I have? Okay, another question here comes up is how much does FileCatalyst cost? Well, FileCatalyst cost is, as I mentioned, we have two different types of licensing modes. One is the unlimited, the other one is a la carte. The a la carte, you pick and choose what you want. So it really depends on your bandwidth and your deployment. I would say starting price for a perpetual lifetime license is somewhere in the range of about $4,000 to $5,000, and can go up from there. It really depends on the applications and software you want to deploy. I would encourage you to contact our sales team or one of our partners to get a quote if you have an idea what you're trying to deploy. But I would say, starting price would be, as I said, for a perpetual license would be probably about $4,000 to $5,000 to get started with it. The monthly stuff, it really depends once again on the packages you want. So it's not an easy question without knowing your full deployment. So here are some of these are the two questions that I got, plus the questions I've already compiled. Thank you very much for attending to my webinar today. Please keep us in mind if you're visiting any of these trade shows coming up. We're going to be in Norway at the end of August for offshore North Seas. We're going to be in the pavilion. I believe it's the Canada Pavilion. So we're gonna have a booth there, and then also don't forget one of our major shows that we do every year, and it's the IBC International Broadcasting Conference in Amsterdam. It's always in September. We're going to be there again in Hall 7, same spot as we've been for the last 5 years. Come and see. We're going to have some new product announcements and enhancements to existing products, so come and check out the demos. And of course, don't forget our monthly webinars. So we usually post them a week or so after this webinar is published, and can you come and join us for that. So once again, thank you very much for your participation today, and talk to you next month. Bye.